Oh, welcome to the class. This our topic today is rectilinear motion. Rectilinear motion. The word rectilinear is derived from straight. The word linear is straight. So, but before we talk about rectilinear motion in details and parameters used to describe rectilinear motion, let's talk about something we call kinematics. In our further classes, we talked about something like force causing motion. Talked about force causing motion, a push, a pull, force field. So, but when we study motion, we study it in two dimensions. We study motion and the bodies in motion without considering the force causing the motion. We also study motion and we study motion and consider the force causing the motion, meaning the study of motion is divided into two, meaning sometimes we study only the body in motion without getting involved with the force that brought about the motion. Secondly, we also study motion and we study motion and the force that caused the motion. So when you study motion without considering the force that causes the motion, that study of motion is called kinematics. It's called kinematics. But when you study the motion and also study the force causing the motion, it is called dynamics. So kinematics you study without considering the force, but dynamics you study the motion and also study the force causing the motion. So that's the difference. Now, rectilinear motion is all about kinematics. We're going to talk about motion, but not considering the force causing the motion. So from here, we're going to start discussing the parameters that we use to describe motion. We'll talk about speed, which is distance over time, which is s over t in meter per seconds. We'll talk about velocity, which is displacement over time, which is also s over t in meter per seconds. So the representation is the same, s over t, s over t. So, but this is a scalar quantity and this is a vector quantity. Now, we have acceleration. Acceleration is equal to velocity, change in velocity over time, which is v over t in meter seconds minus 2. So that's the difference. So from here, you have speed, velocity, and acceleration. So from these three, we can bring our terms together to talk about the equations of motion. Deduction. From a deduction, let's see it from here. If a body is moving with an initial velocity u, and with an acceleration It's an acceleration A. Comma, it is found to reach a final velocity v in a time t when it has traveled a distance s. Full stop. This distance is given as s is equals to average velocity divided by time. Average velocity, this is the other one. Average velocity times time. Now, for the average velocity, that's s is equal to average velocity, that's v plus u over 2 into bracket t. So average meaning half of it. So average velocity times time. So please, this equation, you keep it. Very important. Maybe the second. I'll take the third one by saying, recall that acceleration is change in velocity divided by time. So therefore, what's acceleration? V minus u over t. So from this statement, it's easy for me to cross multiply. What do? I have v minus u is equals to at. If I move the minus u across, it becomes positive. So v becomes u plus at. So this is the second equation of motion, which I'll put there as the third equation. Now, I have one. S is v plus u over 2 into bracket t. That's the first. So the second is v is equals to u plus at. Don't forget what they stand for. S stand for distance, measured in meters. V is the final velocity. U is the initial velocity. And t means time. Okay. Initial velocity, what you're trying to call initial velocity is the velocity at which you started the motion. It can be anything, it can be 0, it can be 2, it can be 4. The velocity at which you started the motion is the initial. Now the velocity at which the motion finally ended is the final velocity. And this is the time taken for the whole motion. The same thing here, you see. So you have V for final velocity, U for initial, A stands for acceleration of the body or deceleration of the body. Now, okay, now from here, from these two equations, I recall this. S is U plus V over 2 into bracket T. Also, V is equals to U plus AT. Is that also? Okay. That's equation 1. Let's bring them together. So from here, I can use the same one. From here, I can make T the subject of the formula. That is, what I get here is T is equals to V minus U over A. I can get this from here by making T the subject of the formula of this equation. So after making T the subject of the formula, I cannot replace this value now and put it into this equation. How do I do that? Let me put it here. So from here you have S will give me U plus V over 2. U plus V over 2 into bracket. T now is what? V minus U over A. So if you multiply them together, what you get is V plus U plus V over 2 or V minus U. 2 times A, that's 2A. That will give us something different. That's still the value of S. So from here, this value is the same thing as V squared plus minus U squared over 2A. And somebody asks a question, how did the value U plus V minus U become V squared minus U squared? It's called difference of 2 squared. There is no difference between these two values. The only difference is that one of them is positive and the other is negative, because this value here can also be V plus U. De Morgan's rule. The reason is because in mathematics, 2 plus 3 is equals to 5. 3 plus 2 is equals to 5. So De Morgan's rule. Now from here, so U plus V, V minus U, difference of 2 squared gives you this value. So automatically I will now have S is V squared minus U squared over 2A. If I cross multiply this, I will have V squared minus U squared is equals to 2AS. So therefore V squared will give me U squared plus 2AS. The reason is because this is minus. If it crosses the equality sign, it becomes positive. So this is my third equation of motion, which I will name 4. Now, I'll take the last equation. Now, from the two equations that I have, it's easy for me to say that the first equation here is S again, is V or U plus V over 2T. And the other one is V is U plus AT. All I just need to do, I don't need to bother, I just take the values. The value of V, I just replace it here. So that becomes S is U plus, this is V. But here, this is the value of V. So I replace it, what will it become? U plus AT all over 2 into bracket T. So if I have T to be this, if I open the bracket, I will have S is U plus U, that's 2UT plus AT squared all over 2. The question now is, I will need to cross multiply. So if I cross multiply, or if I decide to divide through, so I will have S is, if 2 divide this, that will be UT. If 2 divide here, it will be half AT squared. So this is the fourth equation, which I will regard as the fifth. So the equations are S equals to UT plus half AT squared. Good. Now, let's remind this again. Put it at the box point. You take this at box point. The first one is V is U plus AT. Second is S is V plus U over 2 into bracket T. You have V squared is U squared plus 2AS. And the last but not the least is S is UT plus half AT squared. So these are the 4 equations. So 1, 2, 3, 4 equations. Good. Now we have this. So take 1 or 2 questions. So yeah. So from here, let's bond with this first as example 1. Okay, a body moving with an initial velocity of 25 meters per second reach a final velocity v in 6 seconds. Calculate the value of v if the acceleration of the body is 4 meters per second squared. So we'll take the question now. A body moving with an initial velocity of 25 meters per second reaches a final velocity v in 6 seconds. Calculate the value of v if the acceleration of the body is 4 meters per second squared. Now this is it. Whenever you want to take these questions, it's simple. There is no magic in it. Very simple. What you do is, as you are reading the questions, you start to mark them out one by one. First of all, I want to mark this out. I'll look at the question and say, good. A body moving with an initial velocity. Oh, I immediately know that this is initial velocity. U. I know that. Reach a final velocity. V. Oh, this is the final velocity. But fortunately for me, the final velocity has no value. It is the value of V. Good. In 6 seconds. Oh, the time it took is 6 seconds. I'll put small t there. Small letter t. So from here I say, calculate the value of V. Oh, this is what I'm looking for. If the acceleration of the body is this. So I was even given the acceleration. The acceleration of the body, A. So after that, I will now look at the statements from my equations. All the equations I'm having. 1, 2, 3, 4. Which of the equations, all these equations, let's bring them out. I was told that U is 25 meters per second. That's the first. I was told that the time is 6 seconds. And I was told the acceleration is 4 meters per second squared. But I was told to find V. So, from here, you'll be able to locate that this is U, this is T, and you now know that this is V that you're looking for, and this is acceleration of the body. Now, you first of all outline all of them as a young physics student. You outline all. After outlining everything, you see the way it's outlined. U this, T that, A that, V this. So V is what I'm looking for. So what I do is, after outlining it, I'll go back to my 4 equation, which is here. Well, I look at the 4 equations. Which of these 4 equations have all these parameters? All together, all the 4 parameters are there. I look at it. The one that have it, oh, looking closely, you observe that this equation here does not have V, so it cannot work. This equation here does not have T, so it cannot work. This one, it cannot work. It has no A. But this one can work, the first one. So what are we going to use? We say using V is what? U plus AT. That's how you know the equation of motion that will suit or be suitable for your question. Now take a look at this. Here you have, oh, we're looking for V. What is U? 25. We have A to be 4, and we have T to be 6. So from here we have 25 plus 4 times 6. Surely, that will be 24. So, from there, what next? That's 24. 24 plus 25. What would that become? That become 49 meter per second. So that's the value of V. Now, when you are given values that has to do with distance and acceleration, you can either use this or this. But when time is not involved, you use this. So we'll pick another question